Assalamu alaikum warahmatullah. Hello my dear students. Today inshallah we're gonna start in lesson 1 in unit 2, which is talking about the properties of sound waves. Now first, what's meant by sound? Sound, it is an external stimulus that affects the ear and causes hearing. Nature of sound waves. Sound waves are mechanical longitudinal waves. They are mechanical because they need medium to travel through, and they are longitudinal waves because they are consist of compressions and refractions. Sound velocity, it is the distance that covered by sound waves in 1 second. Sound wave velocity can be calculated by this law. Sound wave equals wave frequency times wave length. Audible sounds can be classified into two things. Number one, musical tones. Musical tones, they are the tones of uniform frequency, like violin, piano, and right pipe. Number two, noises. Noises, they are the tones of non-uniform frequency, like drill, loudspeakers, and horns. Now we'll take the properties of sound. We have three properties. Number one, sound pitch. Number two, sound intensity. Number three, sound quality. Sound pitch, it is the property of sound that distinguishes between harsh and sharp voices. Sound pitch increases by increasing the frequency and vice versa. By increasing the length of the string or the vibrated segmented part, the frequency decreases, and this is inverse relation, like if we see here in this image. By increasing the length of the string, the frequency decreases, and by increasing or by decreasing it, the frequency increase. So it's inverse relation. So by increasing the length of vibrating air column, the frequency decreases and vice versa. Savaart's wheel. How to determine the pitch of a sound by Savaart's wheel. Number one, listen to a tone you want to determine its pitch. Number two, rotate Savaart's wheel at the same time one of the gear's teeth contacts a flexible metal, steel, or metal sheet. Number three, increase the speed of rotation till you hear a sound similar to that of the unknown tone. Number four, calculate the number of cycles taking place in a specific duration, and by knowing the number of gear teeth. Sound frequency can be calculated from this by this law: number of cycles times the number of gear teeth over time in seconds. And speed of rotation can be calculated by number of rotations divided time in seconds. Sound intensity, it is a property of sound that distinguishes strong and weak sounds. Examples: shouting is stronger than whispering, cannon is stronger than rifle. Cannon stronger than rifle. Okay. Sound intensity measured by quantity of sound energy falling perpendicularly in 1 second on a unit area. Sound intensity measured by watt per square meter, and sound noise measured by decibel. Factors affecting sound intensity: the distance between the sound source and the ear, the amplitude of sound source, the area of the vibrating surface, the density of the medium through which sound travels, and direction of the wind. Number 1, the relation between the distance between the sound source and the ear and the intensity of sound. If we see here in this image, which position is the sound intensity the highest? Yes, it will be number A. Then it will be decreases in position B and decreases in position C. Inverse square law of sound. Sound intensity at a point is inversely proportional to the square of the distance between the source of sound and that point. Number 2, the effect of the amplitude of the sound source on the sound intensity. Sound intensity is directly proportional to the square of the amplitude of vibration of the source. This figure represents two sound waves, A and B. Wave A is higher amplitude and therefore it's louder. Number 3 is the effect of the area of the vibrating surface, resonance box, on the sound intensity. When the source of sound touches a resonance box, the air in the box vibrates, increasing the sound intensity due to the increase of the area of the vibrating surface. If we see here in this image, this mobile phone, if we approach it to this resonance box, its sound increases. Number 4, the effect of the density of the medium on sound intensity. Sound intensity is affected by the density of the medium that transmit the sound. Sound intensity increases as the density of the medium increases. Number 5, the effect of the wind direction on sound intensity. Sound traveling in direction of the wind are louder than sound that travels against wind direction. Okay, if the sound with the wind direction, it will be louder than if it against the wind direction. Okay. Property number 3 is sound quality. The property by which the ear can distinguish between different sounds according to the nature of the source, even if they were of the same pitch and intensity. Again, so sound quality property, ear can distinguish between different sounds to the nature of the source, even if they were the same pitch and intensity. Harmonic tones. They are the tones that accompany the fundamental tone, but they are higher in pitch and low in intensity, and they differ from one instrument to another. The tone that produced from violin is differ from that produced from piano, and so on. Classification of sound waves. Number 1, infrasonic waves. Number 2, sonic waves. Number 3, ultrasonic waves. Infrasonic waves, they are less than 20 Hz. Examples like the sound produced before rainfall. Sonic waves, its frequency between 20 Hz and 20 kHz. Sounds can be heard by the human ear. We can hear it. Ultrasonic waves, they are more than 20 kHz. Sounds produced by bats and dolphins. Real-life applications on ultrasonic waves. Number 1, in medical field. It used in breaking down kidney and uretary stones without surgery. Number 2, diagnosis of prostate cancer. Number 3, discovering the malignant tumors. In industrial fields, they are used in sterilizing milk by killing some types of bacteria and stop the action of some viruses. Number 3, in military field, they are used in finding landmines.